An algorithm is a set of instructions. That's it. That's the video. Now, please like, comment, and subscribe. I'm just kidding. Well, a set of instructions is kind of like the headline of what an algorithm is, but it is a bit more complex than that. So let's find out. Now, when you think of an algorithm, you probably think of computers. Which is good, because computers essentially run on algorithms. But before we dive into that, let's take a real-world example as a metaphor first. Let's say you're going to bake a brownie cake, but to do this you need a recipe, right? And the recipe needs to be followed step by step. You cannot skip a step or mix up the steps. Like in our example, if you were going to go for step 3 before step 2, for example, and melt the chocolate in the bowl before rubbing it with the butter first, you would probably end up burning it. And the same principle goes for algorithms. An algorithm is just a recipe with a finite sequence of instructions that together will end up solving a specific problem, which in our case is trying to bake the chocolate brownies. And to solve this problem we need the ingredients as well as the recipe itself, meaning the algorithm. So to quickly sum up, a traditional algorithm typically involves 1. An input, meaning what goes into the algorithm. 2. Some logic, meaning the algorithm itself. Then 3. An output, meaning what is produced by the algorithm. And in our glorious example, the input are the ingredients, the logic is the recipe, the output is the finished cake. In a real-world scenario of a computer algorithm, we would of course need to replace the steps in the recipe with a coding language that the computer will be able to understand and process. So let's get into a proper real-world scenario with a common computer algorithm. One example of an algorithm can be, for example, to find the largest number in a list of random numbers. In order to find the solution here, we need to look at every number in the list one by one and compare them to the largest number that we have found so far. In pseudocode, the algorithm looks more or less like this. So on the first line we have if L.size equals 0, return null. Here the L stands for list, meaning the list of numbers the algorithm receives as input. And if there are no numbers in the list, then there is no largest number, right? So the algorithm will just return null. Then on the next line we have largest n equals L0. So assuming that the list is actually not empty, then we set up something called a variable that will store the current largest number. In our case, the variable is called largest n, meaning largest number. We set this to be equal to the first number in the list for now, which is L0, meaning element 0 in the list. In programming, the first element is usually 0 and not 1, just a heads up if you're new to programming. Now we go into a little bit more of a complicated part of the algorithm, because now we go into something called a for loop, which basically just goes through the entire list of numbers, one by one. So basically the first line says, for each number in list do, meaning do each of the 2 lines below. If number is greater than largest number, meaning if the number that we're currently working on is larger than the current largest number, then we say on the next line, make this number the current largest number. And then we go up to the for loop again on the next number. And then we check again and again and again until we are done with the list. Then at the end we just return the largest number, meaning the output. This is of course a very simple algorithm that takes some input, which in this case is a list of numbers, and then outputs whatever it was designed to output, which in this case is the largest number in that list. Now, there are of course algorithms out there that are a little bit bigger and more complex than what we have looked at so far, and we are going to explore more about those algorithms in the videos about, for example, machine learning. But the idea is the same. It receives some form of input, and then it takes that input and applies some form of calculations on it, and then at the end of the algorithm we get our desired output. Thanks for watching, please leave a comment and see you in the next video.